Hello and welcome to Rick's RC Flying Channel. This is episode 13 of the Sweet and Low build. In this episode, we're going to look at the progress that has been made on the fuselage, and we'll talk about how it was done as it was being put together. So where we left off on the previous video was the fact that the wing had to be mounted onto the fuselage. Now, as far as the attachment points, we have, of course, these wing blocks in here. They're hardwood. They're an inch thick. So you have two choices. You can drill and tap these, in other words, thread them for the appropriate wing bolt size. The ones I'm using are nylon 1/4 nylon bolts. They're from Dubro. And so you can thread these, and that would simply mount there, and you would have plenty of strength there. And of course, like always, with these type of threads, you would reinforce them with thin CA glue. And once the thin CA glue has hardened, you can go with your tap in there again and just kind of clean it out. And you can even do that more than once, just to ensure that those threads are as strong as they can be. Now, when it comes to drilling and tapping those, you can get from Dubro a tap and drill set. Now, this is for 1/4 So that way it assures you, you get the right drill bit size, because that's very important. And then, of course, you get the tap. Now, if you happen to have the tap, but just to remind you, the drill size that you would use would be a 13/64 or a number 7 drill bit. Now, if you didn't want to tap and drill those, you could use a blind nut. And that's actually what I elected to do on this particular build. So these are mounted underneath the blocks, and they're also secured with epoxy. So now we have to put the wing onto the fuselage and make sure that it's properly aligned. So we're going to take the wing, which has been completed, just needs a little bit of final sanding before it gets covered. And the leading edge has a dowel mount, so we know that's going to be lined up correctly. So you place that in there and then lower the wing. Now, as far as the wing is sitting right now on the wing saddles of this fuselage, and you can take at the same points, you can take measurements to ensure that the wing is not sitting on one side higher or lower. Now, we know from the accuracy that the fuselage was built with, and it's been checked, it's sitting properly within the wing saddle of the fuselage. However, though, you can see that the wing can actually rotate on its axis this way. So you could possibly have this leading edge a little forward or that one. So we got to make sure it's lined up correctly this way. Now, you'll mark the center line here on the fuselage and also have a mark of the center line on your tail post. So now what we're going to do, although we did line it up, the center of the wing with the center of the fuselage. Now, when an airplane this size, you may need some help. And what we're going to do is take a measurement from the wingtip to the center of the fuselage. Now, when this process was taking place, the tail was not mounted on the fuselage yet, okay? So we're going to take that measurement from the wingtip, and you may need somebody to help you hold it there. And the measurement on the center line comes in at 54¼ inches. You'll take the same measurement from the other wingtip, and it comes in at 54¼ Now, if one of those measurements was off, then what you will do is adjust the wing by slightly rotating it in whatever direction you need to accomplish equal measurements on this center line on the tail post. Once you've done that, we now are satisfied that the wing is aligned and sitting properly onto the fuselage. Now, you have to hold the wing securely. You may need somebody to help you, especially in an airplane this size. And now we're going to have to drill the holes. Now, when you drill, you have to be a little bit careful on how you align the drill bit. In other words, it would almost feel natural just to take it and drill straight down. Now, of course, before you do any drilling, you've got to make sure that you mark the spot to ensure that you're going to preferably enter the center of that wing block in the fuselage. So you can take a measurement and then plot that on the wing. Now, if you were to drill straight down like this, what happens is that the wing bolt, the head, won't sit flat onto the surface of the wing. Reason being, of course, the airfoil has a curve. What we ultimately want is the head of the wing bolt to sit flat onto the fuselage. We don't want it coming down like this. So what you have to do is make sure that your drill bit is perpendicular to the surface of the wing. So actually, when you're drilling, the drill is going to be at an angle. And by doing that, you ensure that when you tighten these wing bolts, that they seat properly and flat onto the wing. Okay, so keep that in mind. You'll drill through the wing and right through to the wing block. And once that's done, you can remove your wing and then, as we discussed a little earlier, you can either use your blind nuts and tap and drill. Okay, now the next step is when the wing was sitting in the wing saddle, particularly because they were also laser cuts, so there was, an inherent accuracy that kind of came with that. The wing sat very nicely. It was a really nice tight fit in the wing saddle. However, though, there was a few little irregularities, and there's different ways that you can deal with that. Now, in dealing with the seating of the wing on the wing saddle, you can deal with it different ways as you're, trying to compensate for any irregularities, such as any little gaps. You can buy wing saddle foam tape. It has an adhesive on one side. You basically peel it off and then you just lay it cut to fit in here. And that works quite well, commonly used on sport aircraft. Another method, of course, is any of the irregularities, you can try sanding them out. So, you try to get that really nice tight fit. Another method I like to use, particularly on scale airplanes, and I did do it on here as well, is that I mold the wing saddle to the wing. And the way I do that is I use an epoxy filler. So that's a two-part product. And the one I happen to use is called Blaze Glaze. And I'm not sponsored by anybody. It's just I've been using it a long time. I really like the product. It's rather expensive. However, though, a tube of it does last a long time. The last one I had was 3-4 years, and that was, building quite a few airplanes. One thing about Blaze Glaze that I like is the fact that it hardens in less than 10 minutes, and it sands up beautifully. It's very commonly used in the automotive industry. Now, the way you go about molding the saddle to the wing is, now you could use any other kind of filler as long as it's an epoxy type filler because you want the strength. And what you do is you apply a liberal amount onto the wing saddle. And when the wing gets mounted, it will squeeze out on both sides. And that's what you want, okay? So put a liberal amount of your epoxy filler onto these surfaces. Then you take your wing, and that's why we have wax paper on here. Now, the wax paper, you'll notice there's two separate pieces. Because the wing has a dihedral, you don't want to try using just one big piece of wax paper, because of that angle in the wing, you're going to get wrinkles in the wax paper, and you don't want that. So use two separate pieces and make sure that as you apply the wax paper that it's flat, and then you simply tape it to the wing. And now you've got your epoxy filler on the wing saddle. Very carefully mount the wing, line it up with the center line and then place the wing down. Now it's going to squeeze that filler, and it's basically going to mold it to the wing. Now, what you do want to make sure you do is not just leaving it sit like that. You're going to actually secure the wing. And you're going to secure the wing as if you were going to go flying. So you got to make sure it's as tight as you would if you were going to fly the airplane. When you tighten these wing bolts, never tighten one side down and then tighten the other. In other words, you want to kind of go back and forth and tighten them equally either side. You never want to torque one side down really tight and then go and do the other side. So in other words, you basically kind of want to balance it out. You would do that, even when the airplane's finished and you're going to go flying. Always kind of go back and forth and tighten them accordingly. And as I said, tighten it as if you were going to go flying. So there we are. And you leave that till your filler cures, and depending what product you use, when that time is up, then you can remove the wing. Now, the idea of the wax paper is very important because that will ensure it'll just pop right off. Blaze Glaze, the product that I use, if you didn't use wax paper, chances are you're not getting that wing off. It will grab that wing. And so the wax paper is very important to use. So we've removed the wing bolts, carefully lift the wing up. So now you end up with a wing saddle that's molded to the wing. And yes, it has squeezed out on both sides. So you simply take your sanding block and just sand that nice and smooth, both outside and inside. Do not sand anywhere on top of the wing saddle because that has been molded to the wing. So if you were to go to sand on here, you basically disrupt that. So once that's done, and you can then remount the wing, and then we could go about starting to install the tail assembly. So now I've taken the wax paper off the wing and remounted the wing into the fuselage. So now we're going to install the entire empennage, the tail of the airplane. So what you want to make sure that when the airplane is resting onto your work surface, that it is perfectly level. So whatever adjustments you have to make sure that the airplane is sitting level, and you can check it in a few little areas. You can just simply use a level tool. And another leveling device I use, this happens to be a Robard incident meter, and it's extremely accurate. It comes with various attachments. You can check the angle of attack. You can check the hedral. You can make all kinds of measurements. It's a jeweled movement, so it's very, very precise. It's measured in degrees. So, you can use something like this. And so when I look at that, it's showing 0 degrees. And you can check it in a few various areas. So we're happy that the airplane is sitting perfectly level. Another thing you could do is, you have a nice flat surface, you can take measurements at equal points to make sure as well, if you like. Now, the first thing we're going to then install would be the horizontal stab. Now, the saddle area that the horizontal stab will be sitting on, you can take your level and check it as well. And if it's slightly off, then you may have to sand either side to make sure that it is perfectly level. Once you've assured that, so now we know that we're dealing with a very level configuration, Then you can take your horizontal stab and place it on. And of course, the center of the stab is in line with the center of the fuselage. Now, what you want to use, of course, is 30-minute epoxy, so you have some time to work with it. So you put the epoxy onto the surfaces and then mount the horizontal stab. Take a measurement from your wing tip to the horizontal stab, and you want to make sure that you end up with exactly the same measurement, because we want to ensure that the horizontal stab is not misaligned. So that way, both the wing and the horizontal stab are exactly the same. So we know it's lined up with the center. We know that it is properly aligned because we took wingtip measurements. And you double check to make sure that it is perfectly level, in line with the fuselage. Once you're satisfied, then you may use pins if necessary to ensure that you have a nice solid fit. You could even place just weights on. Works very well as well. So once that's cured, putting the vertical stab on is actually quite easy. Make sure, obviously, that it's lined up with the center. Take a square and just make sure that it's absolutely in the vertical position. And again, use 30-minute epoxy. So we're going to just take a look at the radio installation, where we're at with that. It's mostly basically completed. The rudder system has a pull-pull system. It's cables. And I do provide a video on how the cable system is set up in terms of installing the turn couplers with the crimping and so forth. Also, the airplane has 2 push rods, one for each elevator, and they happen to be basically, these are arrow blanks from archery, and you can buy them at any sporting goods store that sells archery equipment. It's made out of carbon fiber. Here you can see that's the one end. Now here were the fins of the arrow, which have been removed. And of course, you purchase them without the tips. And they are hollow carbon fiber, very light, very strong. I have a video that shows you how to turn these into push rods. Very simple to do, very effective. And I use them in a lot of the airplanes. So we have 2 of those, and you can see it exiting here for this elevator. And of course, we have one on the other side. The elevator horn here has been cut because it's going to be reshaped, because I didn't need the full length of it there. So the servo tray is installed, and the servo tray is removable. There's 4 bolts holding it on, so it's very easy removal. You can remove the whole thing. The other thing is I delayed installing the servo tray mounts till I had the push rods and cable system installed, because I was able to adjust the height of the servo tray so that the path that the push rod and cable were aligned with the servo tray. So I didn't have a situation where the servo tray was either too high or too low. I had a particular path, basically a straight line I wanted to follow, and I lined up the servo tray accordingly, and then it was glued, the braces were glued in. And as far as batteries go, the batteries will go up in this area here. The servo for the throttle. So the receiver battery will go in here, and the glow driver system will also be mounted in there. So the only other little thing I thought might be worth mentioning is the receiver switch. I'm using a typical receiver switch. Of course, they can, quite often you'll see them mounted on the side of the fuselage, which is perfectly fine, very commonly used. Although this is a glow-powered airplane, and they definitely are messier than a gas-powered, or obviously electric is very clean. Uh, Gas airplanes, very little residue, but glow engines can, the airplane will get messy with oil residue and so forth. So I'm not a big fan of having to switch somewhere on the side because it could potentially get contaminated. So the cockpit module, which of course is removable, what I ended up doing was installing the receiver switch inside the cockpit. So it's definitely out of harm's way in terms of getting contaminated. I'm using a full-bodied pilot, so all he's going to have to do is lean forward, then I can turn it on or off, and then just he leans back. Easy access from the top. And this is the instrument panel back plate. And once I come up with an instrument panel design, I'll have the laser inscribe the instrument positions, not cut it out, just inscribe them. Of course, that now will be part of a file. And this is just a template right now of the instrument panel face. And I have to just decide the material I might use, like a veneer, like a mahogany or something, and then varnish it. If I want, obviously that antique World War I look. I haven't really decided. Of course, once this is all completed, then it will be glued into place. And if I ever have to remove the cockpit module, that would only be in the case if I have to access the fuel tank compartment. And of course, if you did that, because of where the receiver switch is, I would have to disconnect those plugs. But that would really be a very rare situation. Also, for what it's worth, I have had some of the subscribers mention using this as a compartment for batteries or anything else you want. Now, when this was installed, it was an afterthought. I already took advantage of building a compartment underneath the fuel tank compartment. And because the original Sweet and Low just had a completely flat, solid top to it. Didn't have a cockpit, because you were just going to use a shoulder pilot. And this was flat across here. So this was an afterthought, but definitely could be used as a compartment for batteries and what have you, and then just have the appropriate access hatch. So definitely a good idea. However, for what it's worth, this airplane, because the way the wing has to be mounted, the airplane has to be upside down. And so quite typically, that's the way it sits in its cradle. So whatever access you want or inspect things, having the compartment on this side as well for the battery and the glow driver and the servo for the throttle is convenient. So it's all on one side. You're not flipping the airplane back and forth ever to access anything. Anyways, that's where we are with this project. So it's really, for all intents and purposes, everything is taken care of for the most part. Now it's just a question of sanding and shaping and getting it prepped for a final finishing stage. The fuselage will receive a thin coating of epoxy resin to help seal the wood and also just kind of make it a little bit dent proof. And that's the next phase, is really starting a move closer and closer towards the final finishing stages. Now, I would just like to mention one last thing, because no doubt in this video you have seen this opening here and probably wondering what it's for. Now, with regards to the rudder cable pull system, there's no doubt on the internet, amongst the RC modeling community, there is a wealth of information on the different types of cable setups and all kinds of opinions over whether one is better than the other and the pros and cons. So I'll let you explore that, but I'll just mention a bit about what I have done. Now, generally speaking, with the cables that run to the rudder, they either crisscross at one point with equal tension, or they'll run parallel with equal tension, or they'll run parallel, and when the rudder's deflected, only one side of the cable has tight tension and the other one is slack. Now, that particular one I'm not really fond of. I feel that under certain maneuvers, there could be an aerodynamic consequence with the rudder. However, that being said, what I'm using in this airplane is the cable system where it crosses. Now, I'm using the pull-pull system from Dubro for the 440 threaded coupler ends. They do make one that's 256, and that's for lighter aircraft. And they also make one heavy duty up from this one for, obviously larger, heavier aircraft. Now, you don't have to have the Dubro kit. It's very convenient because it comes with everything you need to do the setup. And like I said, I do have a video where I show how you kind of basically put this all together. Now, my cables just run directly to the back, unobstructed, and as I said, they do cross. Now, the cables that the Dubro provides are basically have a coating. It's kind of like a plastic or Teflon coating, very low friction. And however, they do cross. Now, generally speaking, I've never had previous problems ever with wear and tear on other models where I have the same setup. Although it is prudent, in my opinion, to be able to inspect that crossing of the cables, from time to time. Now, either you'll be able to see it, have an access view from your fuselage, or like in this particular case, I couldn't see it, so I basically provided here a inspection panel. This is where the two cables cross. So after 30 cycles or whatever, I can simply open this up and take a quick look just to make sure that it's perfectly serviceable. And for what it's worth, it also allows me to see these exit tubes. These are small plastic tubes that run inside there. Should I ever want to replace a push rod or the cable system, I can look in there and I'll be able to thread things through because I can see those tubes. And this is simply, when it's closed up, there'll just be a couple of button head screws. Now, with regards to, in my case, where these cables are just basically running straight to the back and they cross, I have another airplane, for example, a Fokker D7, where the entire length of the fuselage, the cables, which is a pull-pull system, and they cross, but they run in plastic tubes, the full length of the fuselage. So where they cross, because the cables are in tubes, they don't make contact. So that is another way of doing it, and it works very well. Now, one last thing I want to mention is that the clevis pivot points here are in line with the rudder hinges pivot point. So this axis point on the clevis is in line with the rudder pivot point. And I really like that setup versus if you have the elevator horns too far back or too far forward. I feel it's important that you try to keep that access point in line. And also, my cables always have the same tension. And, when it comes to that tension, you don't want it as tight as it, on a banjo. There is some flexibility. As you can see, I can move it back and forth about a half an inch either way. So that is the way I set up my cable system. And I hope that just explains why I have that opening there. So if you have any questions or comments, I always welcome them. If you like the video, please select like and subscribe. I always appreciate it. Thank you for watching, and we'll see you soon.